Welcome aboard to Ship's Tech Talk, your go-to channel for all things maritime technology. In today's episode, we'll delve into the fascinating world of circulators used in radar transceiver units on ships. Circulators play a crucial role in directing the flow of radiofrequency signals. Imagine them as traffic controllers for radio waves. Circulators are typically cylindrical or rectangular in shape. This is a circulator fixed inside a radar transceiver unit. The primary purpose of a circulator in a radar transceiver unit is to separate the receiving and transmitting circuits of a radar. During the transmission of microwaves, it isolates the receiving circuit. And, during the reception of echoes, it isolates the transmitting path. By using a circulator, we can transmit and receive microwaves using only one radar antenna. Moreover, the circulator protects the highly sensitive receiving circuits from the high-powered transmitting signals. The working principle of circulator. Circulators are typically made using ferrite or other magnetic materials. These materials exhibit a property called Faraday rotation. When a radiofrequency signal passes through a magnetic material, its polarization plane rotates due to the material's magnetic field. This rotation is proportional to the strength of the magnetic field and the distance traveled through the material. Port configuration and signal flow. In a basic circulator setup, there are typically 3 ports labeled as Port 1, Port 2, and Port 3. The circulator's magnetic field configuration and design ensure that Port 1 to Port 2, signal passes through with minimal loss. Port 2 to Port 3, signal passes through with minimal loss. Port 3 to Port 1, signal encounters high Faraday rotation and is effectively blocked, providing isolation between the ports. Applications and advantages. This non-reciprocal behavior of circulators is crucial in radar systems and other RF applications where separating incoming and outgoing signals is necessary. It allows for efficient signal routing, prevents signal feedback, and ensures the integrity of sensitive receiving equipment. In essence, circulators exploit the magnetic properties of materials to control the flow of RF signals in a specific direction, offering valuable isolation and signal management capabilities in radar transceiver units. In maritime applications, circulators are vital for radar systems on ships. They also find use in non-maritime areas like telecommunications and medical equipment, where managing signal flow is critical for proper functioning. So, circulators are like silent guardians in radar systems, ensuring smooth signal flow and effective communication. Thanks for tuning in to Ship's Tech Talk. If you found this information valuable, don't forget to hit that subscribe button and ring the notification bell to stay updated on our latest videos. Like and share this video with fellow maritime enthusiasts and tech aficionados. Until next time, fair winds and smooth seas.